So a quick introduction. So what we are trying to do is we are trying to figure out, lay a foundation for what an AI agent is in this world where AI agent versus an LLM to GPT or whatever. There is so much confusion on how things are actually happening. Unfortunately, nobody has come at a precise decision where precise definition which can be applicable everywhere. But I'm going to give my own interpretation, right? So essentially, actually, even better, we go here. So if you have used something like ChatGPT, okay, so which is mostly what started as an AI assistant. Okay, so what does an AI assistant do? Let me open ChatGPT. Right now, if you look at like ChatGPT in general, it is basically an assistant where I say like, hey, what's the what are the different meeting tools available for online webinars? Okay, so I ask a query. Okay, so the A, what it does is based on its internal knowledge. So whatever knowledge it has been trained on, it gives you a response of different options that are actually available. Okay, this is very similar to like an assistant, right? So whom you can simply ask questions, and based on the knowledge the assistant has actually gathered, the assistant will actually respond. Okay, so this is what we mean is it has the ability to provide information. Okay, so how does it do it? So basically, if you see, this is an LLM called GPT-4o, right? It is trained with some data, and we can also augment this LLM with some additional information using concepts like RAG or your own internal data or whatever. So basically, an assistant is something that uses LLM and memory. Okay, that's the same thing. It works with your ChatGPT, DALI, which generates images, or you have video models which are actually being used, or your Claude or Gemini or whatever it actually is. All those LLMs are all essentially AI assistants. Okay, so what they do is they have internal knowledge, which is what they're trained with, and they can also take some memory, which is your RAG or internal memory or whatever, right? And they can provide responses, provide information. Okay. But compare that with what we call agents. The only difference, the biggest difference that AI agents, how they differ from AI assistants, is that they can also take actions. Okay. Action is the ability to not just read, but also update, modify, do other operations, which is very different from simply providing information. Okay, I hope this is clear. Now, an example of so how do AI agents actually work? So one is obviously they have the basic LLM. The LLM is attached to memory, just like assistants. So you take this assistant, and you also give this the ability to work with tools. Okay, so we'll come to what tools are. So ability, and next one is it can also work with other LLMs. So an agent need not be a single LLM, but it can also be multiple LLMs, where multiple LLMs kind of like work together to perform these actions and like some operations or workflows actually together. Okay, so yeah, the main difference is going to be the ability for it to take action. So that is the difference between an assistant and an agent. Okay, example of this is, if you remember GPT, so they have something called where is the tasks? Okay, I don't see it anymore. But and another example is basically using search. So the way it actually works is you have an LLM. The LLM will, so there is a, let's say, a Google search API. Okay, so you'll have a Google search API and you have this LLM. So what you do is you tell the LLM, hey, if you ever want to search for a particular term in Google, this is how you do it. So that is a definition you will actually provide to the LLM. So this is not trained with LLM, it is external. You simply provide that as an instruction. If you ever want to use this, this is how we actually use this particular tool. Okay, so Google search is a tool. You can use something like calculator. In if you have used all these Lovable or Claude or whatever, the ability to edit code or read code, etc., become tools. Okay, Like for example, if you want the LLM to use calendars, so calendar is actually a tool. Or if you want to use deep research, that is also a tool. Okay, and especially here, so if you use ChatGPT, there's an ability for the ChatGPT to connect your, your Notion or notes or whatever it actually is. So these are also tool capabilities. Okay, essentially you connect, you tell the LLM how do I connect, use the tool. So if the LLM learns how to use the tool, obviously it can operate using the tool. Okay, so it can, if you take something like notes, it can create a new note, it can edit an existing note, it can delete a note, as long as you give access to the LLM saying how to use notes. Okay, so essentially in case of an agent, what we do is we tell the LLM how to use tools, and the tools can be something simple like any of these apps, or it can be a simple program. The program can be how do I use my internal what do you call database? How do I access my internal database? So that can be an external API, or it can be a simple snippet of code, or it can also be another agent. Okay, to an LLM, it is using another internal tool. So that's how it is. I saw a question on MCP. So MCP is an easier way to access tools. Okay, so you think of tools. Let's say you have like hundreds of tools you're managing. So how do I easily manage all of those tools? Is basically where MCP comes in. So we have done other sessions on that. So I don't want to dive deeper. But towards the end, if there are more questions, we can discuss around it. Okay. Now this is. I hope this is clear. Just feel free to interrupt and ask. So yeah. So an agent is something that can take action using tools and other LLMs basically. Now, an example of this is, I can't see it right now. I think they've integrated, is basically GPT or your OpenAI has the ability to create tasks. So you can say that, hey, just send me a reminder every day on whether I have, uh, reviewed my calendar. And every week you want me to remind me saying that you can actually do this. So it used to store it in a temporary tool called your reminders. It's basically an internal calendar, and it responds on the particular time. So that is the tool. OpenAI operator is where it checks it accesses your browser and does things on your behalf. So that is also a different tool. OpenAI researcher, the deep research that you see, which is also something that Claude has, your Perplexity has, your Google has, your Grok has, everybody has it now. That is also a way of using tools. It's slightly more complicated than this, but you can also think of that too. In fact, in today's session, we're going to see how we build a researcher like this on our own. Okay, so it should be done in like 15 minutes, but we're going to build the researcher ourselves. Okay, so examples of assistants, where do you use assistants? Simply you want to summarize text, or you want to write emails, or you want to write a marketing email, or you have a big PDF, you want to do some analysis, etc. So what you do is you simply upload it to your LLM assistant, and the assistant summarizes based on the knowledge it has. In case of agents, again, actions. So you can probably book tickets. If you tell it how to use, let's say, an Expedia, it can go ahead and book tickets. It can send emails, right? So in this case, assistant can only write emails, but your agent can actually send emails or receive emails, read from databases, schedule calendars, etc. All of those things. Okay, so that's the main difference. Now moving on. Where do I use agents? These are the three main areas that I have seen it where it actually works well. One is open-ended problems. Open-ended problems is, if I want to do a simple research or a question like this, I place the question, it gives you an answer. But instead of this, let's say there is a lot of back and forth. In case of think of something like calendar scheduling. The scheduling depends on I send a instruction to the agent saying that schedule a meeting. The agent will have to see whether the meeting availability is there. It has to figure out whether the other person's availability is there. Can I access the other person? If it cannot access, I need to ask the main person for the contact details, permissions. And if I have permissions, I need to call the secondary person saying if they have availability, come back, refine, create the final calendar invite and send. Right? So it's a very open-ended problem. So in those cases, you end up using agents because a lot of thinking, a lot of processing, a lot of back and forth actually happens. Similarly for agreement signatures, which is also a very, very similar concept. Now, the second one is a multi-step process. Multi-step processes, for example, take all the articles for a given topic and summarize them. Now, it is not like you are just giving one article and summarize give this, but if you have, like, let's say hundreds of articles, you won't have a context window in your LLM to summarize all of those. In those cases, you can have like multiple summarization agents, you have like groupings, you have matches and other things you can process at a much wider angle. And third is self-improving systems. If you have seen here, so you'll have this, I don't know whether they still have it. So they have this thumbs up, thumbs down, which actually helps this agent learn whether it has done a good job or not. Okay, so these are like feedbacks. So if you're having customer support, you have a customers writing emails, let's say your agent is responding, depending on the NPS the customer is actually giving, you can feed it back into the agent saying whether it is doing a good job or not. Okay, so in those kind of systems, you actually want to use agents. All right. Now, again, this is something we saw already. What are the three building blocks? So one is the LLM, memory systems, and the third is tools. Right? So these are three building blocks of an agent. Now, quickly, what we will do is, so one thing that I have actually seen is, I want to set a context is, it is actually not at all hard. If you are a non-technical person or if you are new to all of this, please don't get afraid. It is actually much simpler than what other traditional development that I have actually seen. It is very easy to understand. It's very straightforward, and even complex systems like this Curse's coding assistant or whatever you actually see are all very, very simple. It is extremely simple for us to understand and even build, for that matter. The way I would actually approach it is have a very clear objective on what is that you're trying to solve. Okay, write it in like a piece of paper, write your flow chart. That actually helps quite a lot. Then figure out the right platform. So there are a lot of platforms which are available. The main ones are if you're a non-technical or semi-technical person, or you want to do it much faster, Zapier, your NA10 are all there, which is all slightly paid. There are also platforms like Landflow, right? So this is free. This is something you can use. It is also open source. So NA10 is, we did a session on NA10 last week. So that is also open. So it is paid, but you can also self-host it if you want it as open source. It is also available. There is a platform called relay.app. So this is, we have the CEO of Relay come and teach. You take a session for us. It's just very, very easy and amazing tool to work with. But this is paid. And you'll also have agent.ai. This is by HubSpot, which is again very, very straightforward, but very simplistic. This is also pretty good. And you have a bunch of ones like this. You just go search for a good tools to kind of like work on any of this. You'll be able to figure it out. But I would request you to try a few platforms to understand what actually is easy. And third is start with like small testing, small use cases, test it, start using it. Then you learn more and more. Okay. So before we get into the actual demo, I'm going to show how internal workings of, let's say, 2-3 agents, right? Okay, so we have, I don't have the customer support agent, I have a coding agent. So that's something I'll actually show. But we have a, let's say, a meeting scheduler agent. So let me show you. So let's spend some time on this. I'll try to, it's not as complicated as it actually looks. It's very, very straightforward. Now imagine that you have a meeting scheduling assistant. So what does it do? A meeting scheduling assistant is responsible for, when given a request for scheduling a meeting, it is responsible for identifying the right time slot that is available across all the participants, right permissions for you to send email, and finally create the block in the calendar so they can all meet with the right context. Simple, just like what you would want a human assistant to actually do. So what would you tell a human assistant? You would tell the human assistant, hey, like, can you find 30 minutes, Praveen, for me, like tomorrow? So the human assistant would know what tomorrow is. The human assistant would see if she'll obviously have access to my calendar, because if she's my assistant, then she needs to check whether she has access to Praveen's calendar. If she has access, check whether there is a time slot that matches. If not, ask for a time slot. If she doesn't have access, send an email to Praveen asking for the respective time slot, and finally book a meeting in my calendar. Right? So simple. This is the process that actually happens in case of a human. Exactly same process actually happens here. Nothing different. So now let's say scheduled meeting request comes. So this request typically comes via Slack or email or whatever. Now first it hits an LLM called a triage LLM, which is exactly like your Gemini or your GPT or whatever. It's the same LLM. There is nothing different. The only system prompt will be that, hey, like you are an LLM who's responsible for scheduling meetings. What you actually do is you figure out whether this is a proper scheduling request. If it is a proper scheduling request, you proceed with the scheduling process. If it is a spam or any other like PC information where you don't have to do anything, ignore it. So the triage LLM has access to memory. Okay, there are two memories we do here. So one is historical conversations. That means any message that comes to the triage LLM tracks all those historical conversations in a place. Okay, think of it as you don't have to think of it as a DB. In a lot of cases, it is yeah. So in a lot of cases, it's like a very simple one table or a CSV or a structure. Right, it's very straightforward. The second one is user preferences. Okay, for example, me as a person, I don't take meetings beyond 5 p.m. Let's say, right? I start working at 9 a.m. But let's say I don't take meetings till 11 a.m. And I like my meetings to be like in 30 minutes time slots. I also want a gap between two consecutive meetings. So I'll have a lot of these personal preferences, which can happen over a period of time, right? These can be provided by me, or it can be provided by the LLM. In both cases, it will store it in a file called user preferences. Again, this is not any complicated DB. This is simply what you call a text file, right? In most cases, it's actually a very simple text file, a JSON file for that matter. So the triage LLM will read both of this, figure out how do I triage the incoming request, and then figures out whether it needs to send it to the actual scheduler. Okay, so let's say this is actually a request for scheduling a meeting, and gets into the scheduler. In the scheduler, the scheduling agent is a little bit more complicated. See, it again has access to the memory, where it understands user preferences. But it also has an interesting thing called tools. Okay, so the tool is basically, so the tool selector can be replaced with this MCP concept, right? But we'll not get into that. But let's say this LLM, again, just get another LLM. You can put an OpenAI or a Claude or a Gemini or any open source for that matter. It just needs to know it needs to know when do I use what tool. Okay, this scheduler LLM will give a prompt saying, what is your purpose? Your purpose is to basically figure out the right, given an input, what do you call, time slot and list of people, you need to figure out the right time slot, which is applicable for both all the participants, and book a calendar meeting. If you don't have access to calendar, you can send email. If you want to find the slots in the calendar, you use a calendar tool. And for you to remember all the things that you're doing, you are using a task manager. Okay, so the scheduler will come. Let's say it's between me and Praveen, and it's first checks, hey, I need to check Bala's calendar first. So it goes to the tool selector. It knows how to access calendar. It accesses my calendar. It gets my availability, comes back. Now it has my availability. So it also notes down in the task manager saying that, okay, these are the 5 things I need to do. I need to first get Bala's availability. I need to get Praveen's availability. Then I need to book a slot. Now it goes here. So Bala's availability is checkmark. Now come to Praveen's availability. It checks for calendar. It doesn't have access to Praveen's calendar. Okay. Now the task gets updated saying that Praveen's calendar is not available. So the next step is send email to Praveen and get a time slot. So it uses the email tool to send email to Praveen. Okay. Then it waits for the response. So once the response from Praveen actually comes in, then it updates the slot saying that a response from Praveen has actually coming. Now I have to book the calendar. Again, it uses the calendar tool to book a meeting for the given slot between me and Praveen. And finally, the response goes, the LLM checks that all the tasks are actually done. So the tasks are done, process is successful. Okay, so this is an example of how the whole meeting assistant actually works. And this is essentially how it actually works in most other cases. Are there any questions so far? Is this part clear? All right. Sharad, yeah, go on.
Bala, maybe it's kind of part question, part comment, but like large language models, like strictly, they are just like language generators, right? Like given some like text, it printers the next bunch of text. Like, do you know the internal workings of how it can actually start working as a scheduler? Because scheduling is now intelligence, right?
Yeah, yeah. See, LLMs are slightly more than, so we'll probably do one session on how LLMs are actually built and how they learn, right? Essentially, the current LLMs, at least the large language models, at least the SOTA models, they've come to an ability where they simply don't predict the next token. There is some amount of context and information and some intelligence that has started coming in, right? It means depending on the request, it is able to figure out what is the sequence of tasks and is able to figure out for what task what should I actually use. We've actually practically hit that benchmark today, right? So it is like an easy way to remember is you look at like a dog, right? So you tell the dog to sit first 100 times, it will not even know whether how to associate between the sit and the treat. So it kind of like keeps doing it. But beyond a point, after let's say a year, you ask the dog to sit. You don't have to have a treat, or you don't have to be in the same place, or you don't have to have the same context. The dog knows that sit command means you have to sit, right? It internalizes that like meaning of the sit word to the action that it actually needs to take, right? I can't say like I can't equate the dog brain and like what the LLM actually does, but that is a very, very good analogy. Essentially, that is what we are also seeing. The LLM simply doesn't predict the next token. It does a little bit more smarter than that. But probably we'll spend some time on this in future sessions on how LLMs are actually built. All right. If there are no more questions, I'll quickly jump to next one. Right. So let's quickly see the research assistant also. So I'm sure you guys have seen the deep search assistant in OpenAI, right? If you have not used it, I would request you to really try it. This is pretty amazing. Now, what does deep research actually do? So you give it a topic, it figures out what the topic is about, it asks some follow-up questions. And once you're given an instruction, it gets a lot of source data, and it processes the data to an extent where it creates a detailed report for the given topic. The report is actually of like a very, very high quality, and it is very dense with information, right? Now, this is how internally a deep research assistant actually works. There are minor changes here and there, but essentially, like largely, this is how it actually works across the board. Okay. All right. So here, so let's come to this. Like basically, what you do is you give a topic around it. So first, there is an outline LLM. So in OpenAI, there is one more step where it asks follow-up questions always, right? So that can be another LLM. But apart from this, let's say the research has started. So you first have an outline LLM. So the outline LLM's responsibility is very simple. It needs to figure out for a given topic, what is the structure of my report is going to look like. It first figures out the structure. Okay. How can it use the structure? Again, it has access to a search tool. It uses a tool to figure out what is the right ideal structure for the topic. Okay, and the search gets completed. It comes back to the outline LLM. It can do it a few more times to understand how this needs to be done. And after it is like okay with like the report structure, it saves a structure. Okay, in a temporary storage mechanism. This is probably could be like a JSON structure or simply a text file. Okay. Now what happens is for each of the sections, it sends it to another LLM. So there are another agent, sorry. If you see, there are multiple agents here. And for each of the sections, it has outlined the outline. It initiates this research agent. Okay, so for the first section goes here, the second section goes here, third section goes here, like even if there are 100 sections, just keeps going on. Now the research agent gets a particular section and also gets the overall topic so that it understands what is it supposed to do. And it has access to search. It also will have access to diagrams. It can have access to your coding tools and other things. So this is something you can actually give so that the report actually gets more polished. These are future ideas you can actually implement, right? Now, what the research LLM does is it uses tools to figure out content for a given section. Now, it doesn't end there. There is another LLM gets involved in the same agent. This is agent LLM to LLM tool calling. That is a reflection LLM which qualifies whether the response you've gotten is enough or correct. Okay, and this process continues until the reflection LLM is satisfied. One, or second, then you would have given a maximum number of iterations that you can actually go through. So if one of these, and based on this, it will do the whole process and it will send the final response to the original LLM. And similarly, all these sub agents, end up sending the response to the outline agent at the end. And it could either be the outline agent, or you can have one more agent towards the end who is responsible for, taking all these responses and consolidating into a single large report. Okay, and that is the report that you actually get. Okay, so that's all there is to it. Again, very simple. This is something we can actually do in like some 15-20 minutes. Nothing too hard. I'm sure there are a lot of nuances to what these guys actually do, but from understanding or from getting to the first cut of it, it is actually pretty straightforward. Again, questions on this? Got it. Now, just connecting back to Sharat's question. So I think the motivation is to understand if the LLM is actually smart enough to kind of like take these decisions with tool calls, etc. Some of the things you should notice is if you are doing any kind of like tool calling or some advanced operations or figuring out what the structure is going to look like, you probably want to have a slightly smarter model. Okay, so those models have the ability to kind of like reason and think, and like the thinking models are actually usually pretty good at all of this, right? So that is number one. Number two is like all these like the memory and the storage and the context, etc. So those things become better because they inform the LLM on how to do these things actually proper, right? So there is a good art in terms of like choosing the right LLM for the right purpose also. Okay. Cool. Finally, moving on to coding. So I just took this on the web. I didn't create it myself. Is it done? Is it in the flow coded or is it done through prompts? I will show you, Samir, for this one, right? The deep research. We will show it live right now. I hope it doesn't take too much time, but I will show it live on how it is done. The third is a coding assistant. So coding assistant is basically, it's very simple. Actually, the coding assistant is extremely simple. All it does is it has access to, you give the question in the code. It has access to using its existing context. The context is basically your rules, all the existing code base that you actually have. So what they typically do is they put all this code base in a database. They use RAG as a mechanism to kind of fetch the relevant documents, and they provide a response. Okay, and finally, you have tools to create code. You have tools to update like the code in a VSC and whatever. And you also have a reflection mechanism. So it also a way to check whether the code quality is actually correct, etc. If it is correct, again goes back, and finally it gives you a solution. The chart is a little off. I just took it off the internet at the last minute. Please ignore this. But essentially, you have the LLM. The LLM will have tools to create, update code. It has memory and the RAG context to read which code it's supposed to use, and just kind of like keeps going. Nothing else. It's actually very, very straightforward. Okay. So typically, any agent you take, it's of the same format. So you have a thinking master. The thinking master will have tools. It will have memories, and it will have like the RAG is another concept. So you do all of this, and it keeps getting recursively better. If you have noticed how well your ChatGPT has performed with respect to recent memories, that is the main reason. They started storing memories, and because of that, the quality has become so much better. And with every tool, so now they're adding tools like HubSpot, or they're adding Salesforce, they're adding your Google Documents and other things. So as they keep adding more and more, the quality of responses keep getting better and better. So that is what actually we are seeing in the ecosystem. And there is not science to it. This is very, very simple compounding effect that we are seeing because of all of this. Right? So very straightforward. Okay, so now the theory is done. So we have 20 minutes. Let's try and build this deep research assistant. What do you guys say? All right, so again, so there are multiple ways to do this, guys. Yeah, just feel free to stop me if there is anything. So there are multiple ways to do this. I told you a bunch of tools that you can actually use. You can use many of those. And if you have the ability to code, you can use different frameworks like LangGraph or CrewA or Agno or whatever. We've done some of the sessions in the past. So go have a look. But today, for simplicity's sake and for easier understanding, I'm going to use N8N, right? Just playing around with it in the morning. So this is, I've self-hosted N8N because I use it for a lot of purposes. So I will use N8N, but again, this is just for illustrative purposes. If you want to go do it on any other platform, that the concept remains the same. Okay. So I'm going to quickly rush through this because the concept is something that we've covered. We will try to replicate it as much as possible. Okay. So the first step is, topic or outline. How am I going to send the topic or outline? I can send it via email, right? I have this thing called email trigger. So when an email gets sent, I can use that. But for simplicity's sake, I'm going to use a chat trigger. A chat trigger is basically it's very simple. So let's say I make it active. I go to this webhook. Okay, it's not registered. It says TK ignore. So basically, yeah. So I can send a chat message like this. Hi. Okay. Now, so whenever I send a chat message, I want the next step to happen. So what I'm going to do is that I will send it to. So they have this thing called agents. This is one of the reasons I like N8N. So basically, they have this concept called agent, which is the same as they have kind of like restructured this block. An LLM plus tools, an LLM plus tools plus some amount of memory. So they've kind of consolidated this block, and they've given you the concept of something called an AI agent. Okay. So this is something I actually like because for a lot of folks, you don't need more than this. It is pretty straightforward for you to kind of like implement rather than trying to connect all of this. It's very chaotic if you use other tools. There are two tools I've seen do this very well, which is one is Retool and second is this. I was talking to the Relays founder. Relays founder also said that they're going to launch something very soon on this front. So I'm pretty excited to see what they're going to do. Again, so if you see the agent, so there is a chat model. That means you're going to use the LLM. So you can figure out what LLM you want to use. I typically use Gemini because one, it is cheap, and the second is it is pretty good. I still find OpenAI kind of like better, but it is pretty good at most of these use cases. I'm going to use something like Gemini Flash, right? Okay, and if you want memory, you can use memory, but in our use case, we don't have any memory, right? So we will. Is there a way to rename this? Okay. So outline agent. Okay. To chat node. Yes, connection done. And finally, I need a tool, right? So yeah, in the Gemini, before I connect the chat, I also need to add the authentication. So I have already added one, but you will be able to just go to the documents and get the Gemini API key. Paste it here, click save, it should get connected and you should be able to use it. Okay, pretty straightforward. And Gemini also gives you a fairly good free tier, so you can use that. Now, second is tools. So we're trying to access search tool and a task manager. For simplicity's sake, I'm not going to use the task manager, but let me simply use search. For search, there is something called SERP. There is one more thing called Pavili. I don't know whether they have this. No, they don't have, but they have Pavili, and there are a few tools which are actually available. SERP I again use because there are good amount of free credits. Again, you just have to go to the SERP API. SERP is basically provided by Google. So you go to its site, create an API or a credential, and just add it over here. Right? Simple. Now we have this structure kind of like ready. What we are going to do is we will go and edit the system prompt. So let's say system prompt. I'll say, hey, you are the main research agency. You will get the user input. Pick your research. Your which tool would you suggest for task manager? I'm not sure. I have not used anything for task manager yet. I've been playing around with linear because I know it's a big project management tool. But all my personal tasks are actually over there, so I'm actually using that. But I'm sure there are like simpler task management modules available. Even things like you have, yeah, you Google Tasks, but there are also some other smaller task modules that are actually available. You can definitely explore those. Okay, so topic for research. So you, okay, your objective is to identify structure of the research output and give the list of topics sections in the research output. Okay, so we'll also say that the list of sections output just the list of sections with no numbers or formatting. Okay, so let's see how it actually works. I'm going to click execute step. So the chat inputs, so automatically it picked it up. So whatever chat input we actually gave, it came here. So it automatically picks it up from here. So let's just give chat input. So we can say, just reset this. We can say how did Trump's tariffs impact Europe or what are the short. Okay, so this is understand. Now this is gone to execution. Okay, so now the output is here. So it has given the list of topics. But if you see, it's a little, it's kind of like in the same output. If you want it to be more structured, you can also use something like required specific output format. Okay, so when you do this, you'll have an option to see there is a way to structure the output. The one I like is JSON. There are other ways. Again, these are the areas where you have to get into a little bit of structuring. So, but say actually, let's leave it as it is. Let's not complicate it so much. Okay, so we have a list of topics. Then what we will do is now we have the list of topics as an output. That means we have done the first part. So it goes to search, it uses this, comes back and gives you the list. Now we have to send it to another agent, multiple versions of another agent, which will do this research reflection tools and all of these things. Okay. Now I'm going to create. So right now this is a single output. So I need to split this into multiple ones so that I can send each one to the next agent, right? So I'm going to use something like split. Okay, so I will take output. Okay, so is there a I don't know how this works actually. Fields to split out. Data transformation. Okay, in the interest of time, I'll kind of use a simpler format. So I'm going to use a specific format, and I'm going to use JSON, Let me say section 1 was section the document. Section 2. So this is just an example format that you are giving, right? Okay, so let's try this again. See what happens. Yes, introduction. Oh, nice. So we have 2 sections. Perfect. Right. So it's very nice. Okay. Now let's just see one more problem. So this first section is perfect. So now let's create the second one. So I'm going to create another agent. Okay, so we'll call this research agent. Okay, so the research agent will be to connect it to it first. Also use a chat model. We'll again use Gemini 2.5 and 2.5 Pro. Okay. Now it needs tools like search again. So okay, and it needs to go to another reflection LLM. Okay, so yeah, before this, it needs to send for each item. Yeah, this is going to send for as a whole. We need to kind of like split this into separate items, right? Yeah, I'm just going to split this into separate sections and connect over here. Okay. Okay. Oh, no prompt specified. All right, so I'm going to say you are the research assistant responsible research given larger report. Okay. Now focus only on the section in context of larger report. Okay, so we will say topic is, we will take the topic here. Then we will say we have section. We will say okay. Let's get this. Okay, it is doing the search. It's again doing the research. Right, so let's see what happens. Oh, yes. Okay, we have gotten the result. Bags for grade cinema. Now this we don't know, whatever. Okay, so now we'll keep on going. So what we will do is we need to start storing these results somewhere. So all of these things get aggregated. Okay, so simplicity sake, I'll use Google Docs. Okay, we need to update a doc, but because every time we run a range, it needs to be a separate document, correct? So what we will do is we'll create a document in the beginning. create a document. Use research engines. We will say document's title is, applied AI research, and I'll probably use a session ID as the thing. Okay, so this will be the name of the document, and we will connect the document to this. We need to execute previous notes. Now I will take. Okay, so this can. Now basically what I've done is I've sent a chat message. I've created a Google Doc. Let's see if Google Doc is available. Oh, it's 10:56 already. Yeah, so after the research, this document got created, and then the okay. Yeah, I'm sure we can do this a little better, like in terms of structuring it actually, but for current use case, should be enough. Okay, so now this agent is done. Now we will edit the fields. Okay, so now we have a research agent. We'll execute this, which will do the research. While the research is happening, let me update the Google Doc. So essentially what we need to do is we need to append whatever output we get to the same Google Doc. So I'm going to take the doc ID. Do this. Any questions so far, guys? We're almost at the end of time.
There are some questions in the chat.
Okay.
I think one of the questions was, is this tool selection being handled by another LLM or the same LLM? That was one of the questions.
Okay. Yeah. See, the LLM don't need to handle tools actually. So it's very, very simple. Like for example, if you look at Claude, right? Claude launched this thing called tool calling. So they created this whole MCP and other stuff. So for example, Claude has access to web search. If I upgrade, I'll have access to all of these different tools. So Claude is LLM, and you can instruct it. Instruction basically says, how do I access these tools? Okay, it's as simple as a text instruction. So if you see the actual code, it will basically say for this, in order to use this tool for, let's say, web search, this is what you actually use it for, and this is a structure in which you call the web search. So if the LLM understands it, it creates the input structure, and then it makes the tool call directly, right? So that's all it actually does. There is no separate LLM for tool calling. So the tool calling and the actual research LLM is the same. That's what N8N also does. So if you look at N8N, there is nothing inside it. It is just a connector for connecting all of these different nodes. So this is LLM. The LLM is connected to tools, and there is a final output structure process. Yeah.
Samir asked one more question: is the entire flow coded or is it done through prompts? I think it depends on the use case, but yeah, your perspective.
You can use a no-code tool like this to do it. It only scales beyond a point. Like I've been using anything for 6 years. It is very, very good. For most of the personal workflows, it works really well because you don't have to set up projects and other things. But if you are thinking about like production or large scale, the number of edge cases become too much. So that's why the N8N code becomes really, really big and impossible for you to manage. That is a trade-off. But if you're starting, this is a fantastic tool. But it is a little dev focused. You need to understand a little bit of JavaScript. But I have my personal friend here. I always use this person to kind of help me figure out all of this. I tell them I use N8N. This is the problem I'm facing. I even put a screenshot and I get help. So that's what I do.
Have you given any N8N documentation into ChatGPT?
I have not. In the general Google search, it works.
Okay.
Yeah.
Good.
The tool is very good, but they are a little frustrating in the way they work. They are like like pure proper dev folks. They don't even talk a little below a certain level to like the normal people like us.
Okay. Is this a self-hosted version on your laptop or is it running on a cloud? Another question.
Running in my personal cloud, but you can host it on your laptop. I've done that before, right? But this one is running in my cloud.
Right.
Yeah. So use this for some applied AI stuff also. So we kind of host it in the cloud. So yeah, coming back to this, we need to update the same document. Like whatever document, empty document we created, we'll try to update the text in the same document. So what I'll do is, I'll take the ID, just put it over here, doc ID or URL, and it is a text, and you're not doing insert. Right, I'm doing update, right? Operation is update. Okay, or we're not finding insert into body. Or is a text? So I just copy this text and put it over here. So I'm going to click execute. And okay, so now moment of truth. Let's just go here, open this, and yeah. So this is updated. So okay, now we have to figure out a way to kind of like loop this one by one for each of these items. Okay, and finally you can also attach something like a a Gmail, so that send a message. I've already connected my account, so that will work, but we have to connect that also. It's a little painful to connect these accounts. Yeah, I'm not even kidding actually. So let's say, and this is research output for, I can say, right, and messages. Here is the link, and I can the Google Doc, and I can. Oh, how do I attach the link? Yeah, I'm sure there is some structure to the link. So yeah, I think document T. Okay, I'm going to do this. Okay, so works, and finally I can execute step. We connect. This is, yeah, it's been some time since I connected that, right? So now we try again. Okay, so this is uploaded. Oh, I didn't send it here. Let me see. I sent it to the wrong one. Okay. Yeah. So I have a different. So I've got the link, the document, everything, right? So that's about it. So we still have to work on like the looping problem. So we need to do some updates over here, but in the interest of time, I'll kind of like pause here and take any questions.
So two more questions. Does N8N create a binary for the inter workflow? Can I use this from another system as a plugin?
Actually, it does it so much better. So all you have to do is Command A, copy, and you can just paste it anywhere. I'll show you. This is just a JSON. It's not a. It's a good tool that way. So if I go here,
But can I call it from another system, like an API, or how does it work?
Yes. Yeah. So you can, yeah, like for example, you can do. I've triggered via chat, right? So if I make it production, I can just copy it. Just make it active. Got it. Go here. So this is the internal chat that they actually give. Okay. So chat is one mechanism, but again, instead of using a chat trigger, you can do an email. You can use an email trigger. You can use a WhatsApp message. WhatsApp, I don't think there is a trigger, but you can actually do that. Like you can do Slack triggers, for example. So anything, anywhere, even if you update like a spreadsheet, you can actually do this. You can do all of this stuff. The trigger can be pretty much anything with an idea. Yeah. Chat is just easier for me to show the demo. That's the reason.
All right. One final question on the chat. Do we have human in the loop options here and eval integrations?
Absolutely. In the last week, Karthik actually showed human in the loop.
Human in the loop.
Yeah, I think you guys should see that session. That was a pretty brilliant session, focused specifically on NA. Right. So it was quite an amazing session, and he had human in the loop concept for that.
Okay, that's all the questions that we had. If anybody have any specific questions, feel free to unmute yourself and ask. I think we're good, but there are no more questions.
Awesome. Okay, folks.
Super.
Hopefully this was useful. We'll put the YouTube on, sorry, the video on YouTube on Monday. If you do like it, please try to spread the word. Post something nice about us on social media. That'll help other people actually find us easily, and really appreciate it. Thank you.
Thank you, folks.